Hi everyone, today I will demonstrate the creation of a full web application using the open source low-code platform Generative Objects and making use of DBpedia data sources, all in less than an hour. We will create an application to track visited places for a user. Visited places will be linked to comments. A visited place will be linked to a place itself. A place is located in a country, and the place is potentially designed by an architect. Our visited places and comments data will be stored in our application database, whereas the places, countries, and architect are data from DBpedia that we will connect to. Let's have a look at the application we want to build. So we connect to the application and we land on the list of visited places. From here, I can add a new visited place. So let's say that I visited the dancing house in Prague. Here I can already have access to the place to make sure this is the one I'm wanting to connect to. My date of visit, and my description. I now have a new visited place created. I can navigate to it, and I can potentially add comments to my visit. So the same way I can see all the visited places, I can access all the places from DBpedia. I can search, let's say, for the Eiffel Tower. Here it is, so I can go to the page for the Eiffel Tower. I see some set of information. I can access to the DBpedia page from here. I can see who is the architect for this place. And I can see all the tracked visits to this place. I can add a new visited place from here. And if I go back to all visited places, my new visit to Paris is here. I can access also, so I can access all the places and I can see all the architects and look for an architect, let's say Gary. See the page for Frank Gehry. The link to the DBpedia page here, and all the places designed by this architect. All this is data from DBpedia. I can also access to all my countries from DBpedia, look for a country, and display the page here of Australia. So I see the information from DBpedia, the access to the DBpedia page, and all the places in Australia that are in DBpedia. Here, almost 2,000. And I can, for example, from here, navigate to a specific place in Australia. Here we are. So now let's see how we created this application using generative objects. Here is the ontology from DBpedia we want to use for the countries. Here the page for a specific country. This is the ontology for places. And for places we can see that a place can be of different kind. And for the example, we'll only connect to a few of them because we don't want, for instance, celestial body to be part of the places we can visit. Here is a page for a specific place, the Eiffel Tower. And for instance, here I have access to the page for the architect of the Eiffel Tower and the page from DBpedia. This is all the information all the ontologies we want to connect from our application to DBpedia. Here I'm connected to my Generative Objects modeler platform. I have here an empty project, and I will start designing the application. We start by designing the data model, so all the entities for our application. The first entity we want to model is a visited place. So it has an ID as a GUID as a primary key by default, and we will add a few fields. So we will add the title, we will add also the date of the visit as a date-time field, and the description. So this is a long field, and this is enough for our visited place. The next entity we will model is a comment for a visit. It also has an ID as a primary key. It has a date of comment. And the comment itself. For the comment, we will add a specific business rule, a default value for the date, to make sure that the current date is used for the date of the comment. This is the keyword now that we are using here. So we are not modeling the relations now, for example, from visited places to comments. That will be done in the second stage. We will now create the country entity, and here this data is no more in our application database. It's a SparkQL data source. So we remove the basic default database data source, and we replace by a SparkQL endpoint data source that I will configure to connect to DBpedia. And I will set the default language to English to make sure we retrieve English language from DBpedia. And the SparkQL DBpedia entity type is from ontology DBpedia, and the name of the entity type is, it's Yagoo for DBpedia Yagoo for this one, and the type name is this one. So I save my entity, and I will model all the fields. I don't have an ID GUID by default. We will set the URI, the DBpedia URI, to be the primary key. So here we specify it as being the primary key for this entity. Here we will add several fields. We will add the name of the country, and here, since it's a SparkQL endpoint data source, we need to configure it. The type namespace is this one, and the field type name is label as the name of the country, and it's a multilingual field. We will add the long name of the country. This is optional, the DBpedia ontology, and the internal name for the DBpedia ontology that we want to connect to. We will add here the abstract, which is a long description for the country. And this is this ontology, and the type name is abstract, and it is also a multilingual field. We add also what is called, so we will add also the population total as an example, It's an integer, it's optional, and the internal name, the ontology name is population total. We'll add another field called thumbnail. This is for getting an image for the country. In this case, it will be the flag. Now we add the place entity. It's also a SparkQL endpoint data source connecting to DBpedia. So we will configure this properly. Same principle as before. And here, since we don't want all the different subtypes for places, we will here specify all of them one by one. So we want all monuments, and natural places, and historic places, and gardens, and cemeteries. And finally, all parks. And architectural structure, sorry. We save this entity, and we will now model all the fields, starting by removing the default primary key to set it to the array. The name. So the multi-legal fields is to make sure that we retrieve the right language when we get access to the data in DBpedia. And it is linked to the default language we configured for the data source. So we add the abstract. We add the latitude and longitude, so we'll be able to display eventually a map to the place. So this is a decimal. This is the ontology and the field name. Same thing for longitude. This is optional. And we configure the link to the SparkQL data source. We also add a thumbnail. So this is the field that is used in DBpedia to connect to an image representative of the entity. And here we are. So the next entity to model is the architect, also coming from DBpedia. So we configure the SparkQL endpoint data source. And the entity type name is architect. We save the entity, and we will model the fields. Again, the primary key is the URI. we add the name. It will also be the label from RDF schema. It's multilingual. The abstract is the long description for the architect. It's optional. It's a multilingual field also. And we'll also add the thumbnail to have an image for the architect. So, now that we have designed all the entity, we will model the relationship between all the entities. But first, I need to set a title field for all entities. This will be used for the automatic generation of a user interface to make sure that a relevant field is used for listing a given set of entities rather than using the primary key. For the country, it will be the name. For the architect and the place was the name also. And for the visited place, we will put the title. So, now let's go and model all the relationships between all entities. We have one-to-many relationship between visited place and the comment, because for a given visited place we can have many comments. We have a many-to-one relationship between visited place and place. A visited place is for a place, and we can have several visits for a given place. And the entity is mandatory. We have a many-to-one relationship between place and country, because the place is in a country, but it's optional. The country is optional. It's not set for all the places in DBpedia. And we have a one-to-many relationship between place and architect. And the architect is optional. Several places, some places are designed by an architect, but not all of them. Now that I have done this, I need to configure. You can see that on all entities, we have new fields for the relationships that have been added. For instance, here, for the architect, we have a place items link. So we need to configure how to retrieve this from DBpedia. Map this to the DBpedia relationships. So on architect, it's place. For linking to the places. Same here, to link a country to places. Actually, these links are optional because we are using the relationship in the other direction for these entities. For place, the country is linked to a place through this ontology, DBpedia, and this field name. And the architect is linked to place through the ontology DBpedia and the architect file type name. Now that we have modeled or designed our data model, we could also design a full user interface here, but for the sake of the demo, we will use the automatic creation of a user interface for the project. So it will create a default user interface on all the entities we've designed here. This is done. Now if I go to forms, you will see that for all entities we have a given we have an associated form with all the fields placed in a certain order, including the relationships. We have a set of pages, so we have one page for each of the entity we've designed, and we have navigation nodes for all the pages. So now we'll generate my application. First, I need to design the landing page. So this is the page we reach when we first connect to the application, and now I'm generating. So the platform is actually reading the whole meta model we've created and generated code for the target application. So this is human quality readable code. It will also build the application, deploy the database, and deploy the application that is ready to use and accessible here. So here we arrive to the visited places items page. We can create a new visit to a place. Let's say that I visited the Maria P Bridge in Portugal. Here I can see the detail of the place from DBpedia already. This is my first visit to Portugal. So this data will be stored on the application database about the visited place. And my description. Here I have my first visit to Portugal. I can go to this visit. I can add a comment here. This comment will also be stored in the application database. I can see detail for the Maria P Bridge from DBpedia, and I can go to the list of all places from DBpedia. So here I can see that I have more than 300,000 places from DBpedia. I can search the Maria P Bridge, So it's searching DBpedia, and here I can see my place. I can navigate to the page for Maria Pia Bridge and see the information from DBpedia. And I can see my visit to Maria Pia Bridge here from the place, and have access to the architect here, Gustav Eiffel, and all the places designed by Gustav Eiffel in DBpedia. The same way I can see all the places from DBpedia, I can see all the architects. I can search for an architect, Sauvestre, and see the page for this architect, and see all the places designed by this architect. Here, the Eiffel Tower, and the page for the Eiffel Tower. So we can navigate from any place, any entity to any other entity here. And I can have access to all the countries, again from DBpedia. See the page of a country, information from DBpedia, and all the places from DBpedia that are in this country. Here, 121 places in Argentina. Let's enrich the default user interface for our application to make it more relevant to our users. Here we will modify some of the grids, starting by the places grid. So for example, latitude and longitude, they don't make sense to be displayed on the grid, so we will remove these two fields. On our forms, we'll go to the form for a place. So we also remove latitude and longitude. We want to replace them by a map to the visited place, to the place, sorry. So we remove these two fields from the form. And for linking to Google Map, we need to add a new calculated field from latitude and longitude. So we are in the entity place. We will add a calculated field called position. It will be of type string, and it will be a simple expression. So this is a domain-specific language we have to model and generate calculated field. So it will be the latitude followed by the longitude. Oops, here I see that I made a mistake to the field name. So all is checked properly to make sure we actually connect to things that are existing. So I'm changing this. And now I have my field ID to my entity. And I can add here a Google Map field to the position. We will label it map. Oh, we don't need a label for the map. It will be on the main tab, main zone, display order 100. So now that I have added a field, a Google Map field, I need to add my Google Map API here, API key. I will also, by the way, add a security provider to make sure that we connect to the application using an identification, username, password here. So I'll go back to my forms, and I will make a few more improvements to the form for places. First, I will name the form with the name of the place itself to make it more relevant. Since I have the name as the title, I don't need the name field anymore as a form field. I will remove it from here. And remember, we have two tabs, one for the main information and one for the visited places information. So on my main tab, instead of having one column layout, I will have two layouts come out, two columns forms layout to organize all the information into columns. Here I see that I have the architect, the country, the architect, the abstract on the left zone, and the thumbnail image. We will put the URI link and the position on the right column. So I will put this on the right column, the link to the DBpedia page, as well as the Google Map on the right column. And for the thumbnail image, I will change the label to only image. And since country and architect are optional, we will display them only if they are set. So we will have a visibility rule on architect that will be displayed only if architect is defined. So if architect is not equal to null. And the same type of visibility rule on the country that will be displayed only if country is not null. So we also make changes on the country form. We'll delete the name here and set it as the name of the form, the title of the form. And we will do this for all the forms. And use the name of the entity as the title of the form. I will make changes to the grids. Change the name of the grid to make it better. So we'll do this for all the grids. This is just aesthetics, but to make sure we have an application that's more readable rather than the default version. And here we go a bit faster to make this kind of aesthetic changes a bit everywhere. Changing the names of the tabs also to something more relevant. So now I will remove on the visited place form all the tabs and put everything on a single page, because it doesn't make sense here to have two tabs for visited place information. And I remove the two tabs that are now empty. I will change the navigation to not have a root node home with everything under, but really putting everything as root nodes. So all the pages, the link to the pages, we will remove the root node, the parent node home, to make sure that they really show as root nodes. So places will be in position 2. We make the position like 10, 12, 20, 30, 40 to make sure we can easily change, add nodes in between or things like this, right? Without having to change the display order of everything. So same, the comments, we don't need to have a page, so we make it virtual so it doesn't show. And we remove the root home that is now empty. Here, the design model is where we can design the whole HTML appearance and all the layouts, so it's accessible. What I will change is just put a background image on the header. So I'm changing the CSS here. And I can regenerate my application. So we connect to the application and we land on the list of visited places. From here, I can add a new visited place. So let's say that I visited the dancing house in Prague. Here I can already have access to the place to make sure this is the one I'm wanting to connect to. my date of visit, and my description. I now have a new visited place created. I can navigate to it, and I can potentially add comments to my visit. So the same way I can see all the visited places, I can access all the places from DBpedia. I can search, let's say, for the Eiffel Tower. Here it is. So I can go to the page for the Eiffel Tower. I see some set of information. I can access to the DBpedia page from here. I can see who is the architect for this place. And I can see all the tracked visits to this place. I can add a new visited place from here. And if I go back to all visited places, my new visit to Paris is here. I can access also, so I can access all the places, and I can see all the architects and look for an architect, let's say Gary. See the page for Frank Gehry. The link to the DBpedia page here, and all the places designed by this architect. All this is data from DBpedia. I can also access to all my countries from DBpedia, look for a country, and display the page here of Australia. So I see the information from DBpedia, the access to the DBpedia page, and all the places in Australia that are in DBpedia. Here, almost 2,000. And I can, for example, from here, navigate to a specific place in Australia. Here we are.